In his 1988 book, A Brief History of Time, Stephen Hawking wrote about something he called spaghettification. The word was catchy. It was easy to grasp. It described what would happen to an astronaut falling into a black hole. They would be stretched into a long, thin strand like spaghetti. The image stuck. It became one of the most famous concepts in popular physics. But the idea wasn't Hawking's alone. The physics behind it, the crushing, stretching power of tidal forces near a compact object, had been worked out by physicists decades before. They had calculated the brutal mechanics of gravity's gradient. Well, Hawking just gave it a name that everyone could understand. He took a set of cold equations and turned them into a visceral, horrifying image of a human body being pulled apart, one atom at a time. And that image opened a door for millions of people to wonder and to fear what really happens when you fall into the darkest object in the universe. Number 25, your first mistake is getting too close. The escape velocity of Earth is about 11.2 kilometers per second. That's the speed you need to break free from our planet's gravity. A rocket has to fight hard to reach it. The sun's escape velocity at its surface is much higher, around 617.5 kilometers per second. Every object with mass has an escape velocity. But a black hole is different. A black hole is a region of space-time where gravity is so strong that the escape velocity is greater than the speed of light. The speed of light in a vacuum is 299,792 kilometers per second. Nothing can go faster. This means nothing, not even light, can escape once it gets too close. Your journey into a black hole begins long before you feel any stretching. It begins with a simple navigational error. You get too close. Let's say you're in a spaceship. At first, everything seems fine. You're just coasting through the blackness of space. But your ship's trajectory is slightly off. You are being pulled gently at first by an object you cannot see. The black holes are black because they don't emit light. They are functionally invisible against the backdrop of space. You might only detect one by the way it affects things around it. The initial pull is subtle. It's not a sudden lurch. It's a persistent growing acceleration. Your ship's computer would be the first to notice. It would register a constant, slight course correction is needed. The computer would fire thrusters to counteract a pull it can't explain. But the pull gets stronger. The closer you get, the more fuel you need to burn to stay on a straight path. This is the simple, unforgiving math of gravity. The force of gravity increases with the inverse square of the distance. If you halve the distance to the black hole, the gravitational pull on you becomes 4 times stronger. At some point, the pull becomes too much for your ship's engines. You might have the most powerful engines ever built, but they have a limit. There is a point where even firing them at maximum thrust won't be enough to pull you away. You have passed a point of no return, even though you are still far from the black hole itself. You are now in a decaying orbit. You will spiral inward. The process might take hours or days or years, depending on your initial trajectory. But the outcome is sealed. You are going to fall in. This initial phase is a quiet, creeping horror. There's no great drama, no sudden jolt, just the dawning realization that you've made a fatal mistake. You are caught. The universe has set a trap, and you have flown into it. The quiet hum of your ship is no longer a sound of safety, but the sound of a machine trying to delay the inevitable. Every moment you are being dragged closer to a point of infinite density. Your body feels nothing unusual yet. You can still float around in zero gravity inside your ship, but outside an immense unseen force has taken hold of you and will not let go. It's a slow, relentless capture. The numbers on your navigation screen are all that tell you you're doomed. Number 24. The universe bends around you. The path of light is a straight line. That's one of the fundamental rules we learn. But it's not quite true. Light follows the straightest possible path through space-time. And near a massive object like a black hole, space-time itself is curved. The curvature of space-time near a typical stellar mass black hole, just a few times the mass of our sun, is extreme. This curvature is so intense that it creates a phenomenon called gravitational lensing. A black hole's gravity acts like a lens, bending and distorting the light from stars and galaxies behind it. As you get closer to the black hole, this effect becomes your new reality. You know, the view outside your window starts to warp. The familiar pinpoint stars of deep space begin to smear and twist. You'd see multiple images of the same star. Light from a single star behind the black hole could travel to you along several different paths. Some light might pass to the left of the black hole, some to the right, some over the top. Each path is a different length, and each is bent by a different amount. So you would see the same star in several different places in the sky at once. You might see a perfect circle of light, known as an Einstein ring. This happens when a distant galaxy is perfectly aligned behind the black hole from your point of view. The black hole's gravity bends the light from the galaxy all around it, creating a luminous halo around the central darkness. The black hole itself is invisible, but its presence is revealed by this ring of captured, warped light. It's a cosmic bullseye with oblivion at its center. The view becomes a chaotic funhouse mirror. The positions of constellations would be scrambled. You would see distorted funhouse mirror versions of galaxies. Some would be stretched into long arcs, others would be magnified, appearing larger and brighter than they should. The entire sky becomes a swirling, shifting panorama of warped light. There is no longer a straight line. Every direction you look, you are looking through a lens of pure gravity, and this isn't just about distant objects. Even the light from your own spaceship gets bent. If you shine a laser beam straight ahead, its path will curve inward toward the black hole. If you were outside the ship and looked back at it, the ship would look distorted, its proportions squashed or stretched depending on the angle. This bending of space means your own sense of direction is gone. Forward is no longer a reliable concept. The very fabric of the universe you are moving through is being twisted into a knot. You are navigating a maze where the walls are made of warped space and the light itself is an unreliable guide. The universe is no longer the orderly, predictable place you once knew. It's a fluid, distorted, and deeply unsettling landscape. Number 23, you're bathed in lethal light. Black holes themselves are dark, but the region around them can be the brightest, most violent place in the universe. Many black holes are not isolated. They are surrounded by a swirling disk of gas, dust, and debris that has been captured by their gravity. This is called an accretion disk, and it is a place of unimaginable violence and energy. The material in the disk doesn't fall straight in. It spirals inward like water going down a drain. As it gets closer to the black hole, it moves faster and faster, reaching speeds close to the speed of light. This material doesn't just swirl, it's a traffic jam of matter on a cosmic scale. It's gas clouds, stars, planets, anything that gets too close gets torn apart by tidal forces and added to the disk. The particles of matter in the disk rub against each other. This creates immense friction. And friction creates heat. The temperatures in the inner parts of an accretion disk can reach millions or even billions of degrees Celsius. For comparison, the surface of our sun is about 5,500 degrees Celsius. The core of the sun is about 15 million degrees. The accretion disk of a supermassive black hole is many times hotter than the core of a star. An object this hot glows. It shines with an incredible, fierce light. But because the temperatures are so extreme, it doesn't just glow in visible light. It emits radiation across the entire electromagnetic spectrum. It blasts out intense ultraviolet light, X-rays, and gamma rays. These are the most energetic and dangerous forms of radiation. A quasar, which is just an extremely bright accretion disk around a distant supermassive black hole, can outshine its entire host galaxy. A single quasar can be trillions of times brighter than our sun. If you are falling toward a black hole with an active accretion disk, you will be flying into a furnace of radiation. Long before the black hole's gravity itself becomes a direct threat to your body, this radiation will kill you. The hull of your spaceship would be scoured and superheated. Your ship's shielding would fail almost instantly. The 10th rays and gamma rays would flood the interior of your ship. They would pass through your body, shredding your DNA. They would ionize the atoms in your cells, destroying them. You would receive a fatal dose of radiation in less than a second. Your body would be cooked from the inside out. The water in your cells would boil. Your skin would be burned away. Your nervous system would be destroyed. Consciousness would cease almost immediately. It would be a quick but brutal end. You wouldn't even have time to register the pain. You would simply be sterilized, cooked, and vaporized by the sheer energy of the matter falling into the black hole alongside you. The light that makes these objects visible from billions of light years away would be the instrument of your destruction. You would be erased by the death screams of stars and gas clouds being consumed. Number 22. Your clock becomes a liar. Albert Einstein's theory of general relativity, published in 1915, revealed a strange truth about the universe. Gravity is not just a force that pulls objects together. Gravity is a curvature of space-time. And one of the consequences of this curvature is that gravity affects the flow of time. Time runs slower in a stronger gravitational field. This is not a theory, it's a measurable fact. The clocks on GPS satellites in orbit around the Earth have to be constantly corrected because they run slightly faster than clocks on the ground. The difference is tiny, just a few microseconds per day, but it's real. Near a black hole, this effect, called gravitational time dilation, is taken to its most extreme. As you fall toward the black hole, you enter a region of increasingly strong gravity. For you, inside your spaceship, time seems to pass normally. Your watch ticks at 1 second per second. Your heart beats at a normal rate. Your thoughts proceed at their usual pace. From your perspective, everything is fine. But for someone watching you from a safe distance, far away from the black hole, things look very different. To this distant observer, your clock would appear to be slowing down. The closer you get to the black hole, the slower your time seems to run from their point of view. If you were to send a light signal back to them once every second, according to your watch, they would receive those signals further and further apart. At first, they might receive them 1.1 seconds apart, then 2 seconds apart, then 10 seconds, then an hour, then a year. This also affects the light coming from you. As you fall deeper into the gravity well, the light waves from your ship have to climb out. This costs them energy. As they lose energy, their wavelength gets longer, shifting them toward the red end of the spectrum. This is called gravitational redshift. To the outside observer, your spaceship would appear to get redder and dimmer. Your movements would seem to slow down. A wave of your hand that takes you a second would look like it takes minutes, then hours, then centuries to complete. From your perspective, however, something equally strange is happening, because time for you is passing slowly relative to the rest of the universe. The rest of the universe appears to be speeding up. You would see the distant stars swirling and aging at an incredible rate. You could watch entire galaxies evolve, merge, and die in what feels like a few minutes to you. The entire future history of the cosmos would flash before your eyes. You are in the slow lane of time, while the rest of reality is in the fast lane. Your clock is lying to you about your relationship with the universe. It tells you your time is normal, but you have become disconnected from the universal clock. You are in a bubble of slow time, sinking ever deeper. Number 21. The universe watches you freeze. This is the other side of time dilation. It's what the outside universe sees when you fall into a black hole. It is perhaps one of the strangest and most chilling aspects of the whole process. As you approach the black hole's boundary, the event horizon, the time dilation effect becomes infinite. From the perspective of your friend watching from a safe distance, you never actually cross the event horizon. As you get closer and closer, your clock appears to slow down more and more dramatically. Your image gets redder and dimmer, your movements slow to a complete stop. You would appear to be frozen in time, plastered against the event horizon like a static image. You would remain there, hovering just at the edge for all of eternity, the last photon of light that leaves your ship just before you cross the horizon will take an infinitely long time to climb out of the gravity well and reach your friend's telescope. The light itself is stretched to an infinite wavelength, becoming undetectable, so you would fade away. You wouldn't vanish with a pop. You would just get redder, dimmer, and slower, fading out of existence over, an infinite amount of time. The universe would see you frozen forever at the brink. This creates a bizarre paradox. From your point of view, you cross the event horizon in a finite amount of time. For a supermassive black hole, the crossing is completely uneventful. You wouldn't even notice it. You would continue your fall inward, but for everyone else in the universe, you never make it. You are eternally stuck, so which reality is true? They both are. Reality is relative. Your reality is that you fall in. The universe's reality is that you are frozen at the edge. This isn't just a trick of the light. It's a fundamental consequence of how space-time works near a black hole. The event horizon is not just a physical boundary, it's a temporal one. It separates your future from the future of the rest of the universe. Your last signal, your last image, will be stretched out over all of future time. Anyone with a powerful enough telescope could, in theory, watch the last moments of your fall for billions of years. They would be watching a recording that is playing back at an infinitely slow speed. You become a permanent frozen ghost on the edge of space-time. Your final moment is smeared across all of eternity for the outside world to see, even as you yourself have long since passed into the interior of the black hole to a fate no one can ever witness. Number 20, you cross a line you can't see. The event horizon is the most famous feature of a black hole. It is the point of no return. It is the boundary beyond which the escape velocity exceeds the speed of light, but it is not a physical surface. It is not a wall or a membrane that you would crash into. It is a location in space-time. Well, it is a one-way door, and for a very large black hole, crossing it would be completely and utterly unremarkable. There are two main types of black holes. Stellar mass black holes are a few times the mass of the sun. Supermassive black holes, found at the centers of galaxies, can be millions or billions of times the mass of the sun. The experience of falling into each is very different. For a small stellar mass black hole, the tidal forces at the event horizon are immense. You would be torn apart by spaghettification long before you ever reach the horizon. Your body would be stretched into a stream of atoms, and that stream of atoms would cross the horizon. You would not be conscious for the event. But for a supermassive black hole like Sagittarius A at the center of our Milky Way, the story is different. The event horizon is much farther away from the central singularity because the black hole is so large, the curvature of space-time at the horizon is actually quite gentle. The tidal forces, the difference in gravity between your head and your feet, would be negligible. They would be weaker than the tidal forces you feel from the moon here on Earth. This means you could cross the event horizon of a supermassive black hole without even knowing it. You would just float right through. There would be no sign, no sound, no sensation. One moment you are outside the black hole with the theoretical possibility of escape, however remote. The next moment you are inside and escape is impossible, but you wouldn't feel the transition. The view of the distant stars wouldn't suddenly change. Your spaceship's alarms wouldn't go off. The horror of this moment is in its silence. It is the quietest and most profound point of no return imaginable. You have passed a cosmic threshold, you have irrevocably sealed your fate. You are now disconnected from the rest of the universe. But your body hasn't registered it. Your senses tell you that everything is the same as it was a second ago. It's only the laws of physics that have changed around you. The rules of cause and effect are now different. The direction of your future is now fixed. You are on a one-way trip to the center. The line you crossed was invisible, intangible, and absolute. The universe has let you go, and you didn't even feel it happen. Number 19, your last message will never arrive. Communication in space is limited by the speed of light. If you are on Mars, a radio message to Earth takes several minutes to arrive. If you are near a black hole, this limitation becomes an absolute barrier. As you fall toward the event horizon, the gravitational redshift effect becomes more and more extreme. Let's say you are trying to send a message back to your home base. You send a radio signal. Radio waves are a form of light. As that signal climbs out of the black hole's gravity well, it loses energy. Its wavelength gets stretched. A signal you send at a specific radio frequency will arrive at a lower frequency. Your voice, encoded in the signal, would sound deeper and slower. The closer you get to the event horizon, the more severe this stretching becomes. A message that you intend to be a clear, crisp hello would arrive as a long, drawn-out heel. A few moments later, a second message would be stretched even more. Your words would become an unintelligible, low-frequency rumble. Eventually, the wavelength of your signal would be stretched so much that it would be billions of kilometers long. It would be impossible to detect. It would have effectively no energy left. And then you cross the event horizon. At that moment, any signal you send can no longer escape. It is trapped inside with you. The light you emit, the radio waves from your transmitter, are all pulled inward toward the singularity, just like you are. You can be screaming into your radio, but the signal would just fall toward the center of the black hole. Your last words would be trapped with you for eternity. From the perspective of your friends watching from afar, your messages would simply stop. The last signal they would ever receive from you would be the one you sent just before you crossed the event horizon. And even that signal would be infinitely redshifted and time dilated. They wouldn't receive it as a coherent message. They would just see your signal fading out, its frequency dropping to 0 over an infinite amount of time. You become a ghost in the machine. Your carrier signal is still there technically, but it's stretched out over all of time. No information can be extracted from it. You are silenced forever. You can see the outside universe, but it can no longer hear you. You are in a soundproof room from which nothing can escape. The ultimate isolation is not just being alone in space. It is being in a place where your very voice is trapped by the curvature of space-time. You know, your last message isn't just lost, it is stretched into meaninglessness across the fabric of eternity. Number 18, the future of the cosmos plays out before your eyes. Time dilation is a two-way street. While an outside observer sees your time slow to a stop, you see their time, and the time of the entire universe, speed up to an incredible degree. This effect becomes more and more pronounced as you approach the singularity inside the black hole. Once you cross the event horizon, you are on a journey that will take a very short amount of time from your perspective. For a stellar mass black hole, the trip from the horizon to the singularity might take a few microseconds. For a supermassive black hole, it could take several minutes or even hours, but during that brief trip, you would be able to witness the entire future of the universe play out. Because you are in a region of such extreme gravity, your clock is ticking incredibly slowly compared to the rest of the cosmos. Milliseconds for you are billions of years for the outside world. Looking back out of the black hole, though, out is a complicated direction now. You would have a distorted, gravitationally lensed window onto the future. You would see stars age and die in the blink of an eye. You would see them exhaust their fuel, swell into red giants, and then collapse into white dwarfs or explode as supernovae. You would see nebulae form and then coalesce into new generations of stars. The slow, stately dance of galaxies would become a frantic whirl. You would see galaxies collide and merge. The Milky Way and Andromeda would rush toward each other, their spiral arms interpenetrating, their stars being flung into new orbits, all in a matter of seconds from your point of view. The universe would grow darker as stars burn out. The era of stellar light would come to an end. All that would be left would be the faint glow of dying embers like white dwarfs and neutron stars. Then even they would cool and fade to black. You might even witness the theoretical end of the universe itself. You could see the heat death of the universe, where everything reaches a uniform cold temperature and all processes cease. You would be the last observer, watching the final moments of all of existence from your prison of warped space-time. This is a profoundly horrifying concept. You are granted a glimpse of all of future time, but you are completely powerless to interact with it. You are a passive audience to the end of everything, and this cosmic movie plays out in the last few moments of your own existence as you are being pulled inexorably toward your own destruction at the singularity. You get to see how the story ends, but the price of admission is your own annihilation. Number 17, your feet move faster than your head. This is the beginning of the end for your physical body. It's the mechanism behind spaghettification. And it all comes down to a simple principle. The force of gravity is not uniform over distance. It's called a tidal force or a gravitational gradient. We experience this on Earth. The moon's gravity pulls slightly more strongly on the side of the Earth facing it than on the side facing away. This difference stretches the Earth slightly and is the primary cause of our ocean tides. Near a black hole, this gradient is not slight. It is savage. The force of gravity increases so dramatically over such a short distance that different parts of your body experience a vastly different pull. Let's assume you are falling feet first into the black hole. Your feet are closer to the singularity than your head is. Because of the inverse square law, the gravitational pull on your feet is significantly stronger than the pull on your head. Your feet are being pulled away from the rest of your body. The difference in acceleration is immense. Your feet are accelerating faster than your torso. Your torso is accelerating faster than your head. Your whole body is being stretched. At first, the sensation might be like being on a medieval torture rack. A powerful, irresistible pull on your extremities. This isn't just an external force pulling on your skin. It's a force that acts on every single atom in your body. The atoms in your boots are being pulled harder than the atoms in your ankle bones. The atoms in your ankle bones are being pulled harder than the atoms in your kneecaps. Every part of you is being separated from the part just above it. At the same time, there is another tidal force at work. While you are being stretched vertically, you are being squeezed horizontally. Imagine lines of gravitational force all pointing toward the central singularity. As you fall, all the atoms in your body are trying to follow these converging lines. The atoms on your left side are being pulled slightly to the right. The atoms on your right side are being pulled slightly to the left. This compresses you from the sides, so you are simultaneously being stretched in one direction and squeezed in the others. This process is what turns you into a long, thin stream of matter. You would feel your body being elongated and compressed. The feeling would be beyond pain. It would be the feeling of your physical form being fundamentally disassembled by the raw geometry of space-time. Your body is fighting against the universe's most powerful force, and it is a battle it cannot win. Number 16, your body becomes a noodle. Spaghettification is not a gentle or metaphorical process. It is a literal mechanical dismemberment of your body by tidal forces. As the stretching continues, your body's own structural integrity begins to fail. First, your joints would be pulled apart. Your ankles, knees, hips, spine, shoulders, elbows all would dislocate as the force pulling on your limbs overcomes the strength of your ligaments and tendons. Then your bones themselves would break. Bone has a high tensile strength, but it's not infinite. The tidal forces would exceed the molecular bonds that hold your skeleton together. Your femurs, the strongest bones in your body, would snap. Your spine would be pulled apart, vertebra by vertebra. Every bone in your body would be shattered and separated. Your muscles, organs, and skin would be next. They would be stretched beyond their breaking point. Your flesh would tear. Your organs would be pulled from their moorings and elongated. Your circulatory system would rupture. Blood vessels would be stretched until they burst. Your body would cease to be a cohesive biological entity. It would become a collection of tissues and fluids being drawn out into a long ribbon. This stream of biological matter would continue to stretch and thin out. The process would not stop at the macroscopic level. It would continue down to the cellular and molecular level. The cells themselves would be torn apart as the tidal forces overwhelm the electrochemical bonds holding their membranes together. The complex molecules that make up your body proteins, lipids, DNA would be unraveled. The double helix of Your DNA, the very blueprint of your existence, would be pulled straight and then snapped into pieces. Eventually, the stretching becomes so extreme that it acts on the atoms themselves. The electromagnetic force that binds electrons to their atomic nuclei would be overcome. Electrons would be stripped away, creating a stream of plasma. Even the atomic nuclei would be pulled apart. The strong nuclear force, the most powerful force in nature, would be defeated by gravity. The protons and neutrons would be separated. You are no longer a person. You are not even a collection of organic molecules. You are a thin, hot, glowing stream of subatomic particles miles long but only atoms wide, falling into the singularity. This is the ultimate deconstruction. Every piece of information that made you, your thoughts, your memories, your physical form, is obliterated. Spaghettification is the process of your body being erased from existence, one physical bond at a time, from the largest bones down to the smallest quarks. Number 15, your bones snap without a sound. In space, no one can hear you scream. This cliché is based on a simple fact: sound is a vibration that needs a medium, like air or water, to travel. The vacuum of space is not a suitable medium. As you are being spaghettified, this principle applies in the most brutal way possible. Imagine the moment your femur snaps. On Earth, this would produce a sickening crack. The sound wave would travel through your body, through the air, to your ears. You would hear your own bones breaking. But in the vacuum inside the black hole, or near it, there is no air to carry that sound. The snap would be perfectly silent. The tearing of your muscles, the bursting of your organs, the catastrophic failure of your entire physical structure, all of it would happen in absolute, profound silence. You might feel the vibrations through what's left of your body, a deep, jarring shudder as your skeleton disintegrates. But you would hear nothing. The horror would be entirely sensory and internal, without the accompanying soundtrack of destruction. This silence adds a layer of surrealism to the event. The most violent and destructive thing that can happen to a physical object is occurring, yet it is as quiet as a library. Your world is ending in a silent movie. This lack of sound also applies to your own voice. You might try to scream as your body is being pulled apart. The muscles in your larynx would contract, your lungs would try to force air out. But with no atmosphere, no sound would be produced. Your scream would be trapped in your throat. It would be a silent, futile gesture of agony. Even if you were inside a spaceship with an atmosphere, the sound would be short-lived. The ship itself would be undergoing the same spaghettification process. Its hull would be torn apart, venting its atmosphere into the void. Any sound would last only for a moment before the air to carry it was gone. The experience would be one of pure, unadulterated physical sensation without the psychological component of sound. It would be a direct interface with the raw forces of nature. The snapping of your bones would be a tactile event, a sharp jolt of agony traveling up a nervous system that is itself being destroyed. The silence would be a constant reminder of your complete and utter isolation in this final violent moment. Number 14, your atoms unravel. The process of spaghettification does not stop once your body has been reduced to a stream of molecules. The tidal forces continue to increase exponentially as the stream of matter approaches the singularity. The next level of deconstruction happens at the atomic level. An atom is mostly empty space. A tiny, dense nucleus of protons and neutrons is surrounded by a cloud of orbiting electrons. The thing that holds the atom together is the electromagnetic force. The positive charge of the protons in the nucleus attracts the negative charge of the electrons, keeping them in orbit. This force is incredibly strong at small scales. It's what gives matter its solidity. But the tidal forces near a singularity can become stronger than the electromagnetic force. The gravitational pull on the side of an atom closer to the singularity will be significantly greater than the pull on the far side. This differential pull will stretch the atom itself. The electron cloud will be distorted, pulled into an elongated shape. Eventually, the stretching force will become so great that it will overwhelm the attraction between the nucleus and the electrons. The electrons will be stripped away from their atoms. This process is called ionization. Your body, which was a stream of molecules now becomes a stream of plasma, a hot gas of free-floating atomic nuclei and electrons. This plasma is no longer made of the atoms that once formed you. The carbon, oxygen, hydrogen, and nitrogen atoms are gone. They have been broken down into their constituent parts. The fundamental building blocks of your biology have been dismantled. And the process doesn't stop there. The tidal forces continue to work on the atomic nuclei themselves. A nucleus is a tightly bound collection of protons and neutrons held together by the strong nuclear force. This is the strongest of the four fundamental forces of nature. It is what prevents the positively charged protons in a nucleus from flying apart. But even the strong nuclear force has its limits. In the final moments before reaching the singularity, the tidal forces could become so extreme that they overcome the strong force. The atomic nuclei themselves would be pulled apart, protons and neutrons would be ripped from each other. Your stream of plasma would become a stream of individual protons, neutrons, and electrons. You have been reduced to a soup of fundamental particles. All the complex structures that made you a living being have been completely and utterly erased. Number 13 forward is the only direction. This is one of the most mind-bending consequences of entering a black hole. Inside the event horizon, space and time swap roles. On the outside, in our normal universe, we can move freely in the three dimensions of space: forward, backward, left, right, up, down. But we can only move in one direction in time forward into the future. Time is a one-way street. Once you cross the event horizon, this relationship flips. The direction toward the singularity, which used to be a direction in space, the down direction, becomes a direction in time. It becomes your future. And just as we cannot stop moving into our future, you cannot stop moving toward the singularity. It is as inevitable as the passage of tomorrow. Conversely, the time dimension becomes like a spatial dimension. This doesn't mean you can travel back in time. It means that the path to the singularity is now your timeline. Every possible future path you could take, every possible trajectory ends at the singularity. There are no paths that lead back to the event horizon or to anywhere else. All roads lead to the center. This is not a matter of engine power or willpower. It is a fundamental property of the space-time geometry inside the black hole. Space is so warped that the future for any object or particle inside the horizon is the singularity. Trying to fire your rockets to move away from the singularity would be like trying to fire your rockets to stop next Tuesday from arriving. It's a nonsensical concept. You are being carried forward on a current of time that flows into the singularity. This has a profound effect on what you could perceive. The light from the singularity, if it emitted any, would come at you from all directions. The singularity is not a place you go to, it's a moment in time you will arrive at. It is your future. No matter which way you turn, you are facing the singularity. This makes the interior of a black hole the ultimate prison. It's not a prison of walls and bars, but of warped space-time. An escape is not just difficult, it is logically, physically, and geometrically impossible. Your future has been reduced to a single inevitable point. You have lost all freedom of movement in the most fundamental way imaginable. Your existence is now just a countdown to a predetermined end. Number 12, the stars merge into a single point of light. Your view of the outside universe changes dramatically and terrifyingly once you are inside the event horizon. Before you cross the horizon, you can still see the sky of stars, albeit a distorted one due to gravitational lensing. But after you cross, the view begins to collapse. Because of the extreme warping of space-time, the light from the outside universe can still reach you. But it can only enter through a shrinking window. The event horizon behind you is now in your past. You cannot see it or return to it. The light from the entire universe is now channeled into an increasingly narrow cone in the direction away from the singularity, though. As we've seen, this direction is complex. This window onto the cosmos would appear to shrink. The entire night sky, with all its galaxies and stars, would be compressed into a smaller and smaller circular patch. And as this light falls into the black hole after you, it gains energy. It is gravitationally blue shifted. The light becomes bluer, more energetic, and brighter. You would see the entire future history of the universe playing out in this shrinking, blue-shifted window. But the image would be incredibly distorted and compressed. It would be a bright, dazzling, chaotic spectacle. All the starlight from all of future history would be focused into a single, blindingly brilliant point of light. This point would contain the final image of everything. The last supernova, the last flicker of the last star, the final fade out of the cosmic microwave background. The entire future timeline of the cosmos would be collapsed into one infinitely bright, infinitely energetic, infinitely blue-shifted point. At the same time, the rest of your view would be pure blackness. The region around the bright point would be the darkness of the black hole's interior. You are surrounded by absolute nothingness, with the single exception of this one searing point of light that contains all of time and space. This is your final view. A moment before you hit the singularity, your entire perception of reality would be this single point of light against a backdrop of infinite black. It is the universe's farewell, a final concentrated burst of all its history and light, delivered to you just before your own light is extinguished forever. Number 11. The laws of physics abandon you. Our understanding of the universe is built on two great pillars of 20th century physics: general relativity and quantum mechanics. General relativity describes the universe on a large scale. It's the theory of gravity, of planets, stars, galaxies, and the curvature of spacetime. Quantum mechanics describes the universe on a very small scale. It's the theory of atoms, electrons, photons, and the strange probabilistic rules they follow. These two theories are incredibly successful. They have been tested and verified in countless experiments, but they are incompatible. They don't speak the same mathematical language. In most situations, this doesn't matter. For a planet orbiting a star, quantum effects are negligible. For an electron in an atom, gravity is so weak it can be ignored. But a black hole singularity is different. It is a place where a huge amount of mass is crushed into an incredibly tiny space. It is a place that is both very massive, the realm of general relativity, and very small, the realm of quantum mechanics. To understand the singularity, you need a theory that can handle both at the same time. You need a theory of quantum gravity, and we don't have one. As you approach the singularity, you are entering a region where our known laws of physics break down. The equations of general relativity, which have accurately described your journey so far, start to produce nonsensical answers. They predict a point of infinite density and infinite space-time curvature. Physicists call this a singularity because it's a point where the math stops working. It's a sign that the theory is incomplete. This means we cannot, with any certainty, describe what happens in the final moment. Does space-time tear apart? Does causality break down? Do new dimensions open up? We don't know. You are falling into a blind spot in our understanding of the universe. For you, the person experiencing this, it means you are entering a state of existence that is beyond all known physical law. The predictable cause and effect world you have always known ceases to exist. The very concepts of space, time, and matter as you understand them may lose their meaning. You are falling off the edge of the map of physics. The final moments of your existence would be governed by rules we have not yet discovered. You would be a final, fatal experiment in a realm of unknown physics, and the results of that experiment would be lost with you forever. Number 10, your past is erased. In the 1970s, a deep paradox emerged from the study of black holes, one that pitted Stephen Hawking against other prominent physicists like Leonard Susskind. It's called the black hole information paradox, and it strikes at the heart of what we know about reality. A fundamental principle of quantum mechanics is that information can never be truly destroyed. Information, in this context, means the specific quantum state of every particle that makes up an object. The complete description of a particle, its position, momentum, spin, etc., is its information. If you burn a book, you destroy the words on the page, but in theory, if you could collect every particle of ash, smoke, and heat, you could reconstruct the original book. The information is just scrambled, not erased, but black holes seem to violate this rule. According to general relativity, anything that falls into a black hole is pulled to the singularity and crushed out of existence. The only things a black hole remembers about what it ate are its total mass, its electric charge, and its spin. Two black holes with the same mass, charge, and spin are identical, even if one was formed from, collapsing stars and the other was formed by throwing encyclopedias into it. The detailed information about the encyclopedias seems to be gone forever. This is a huge problem. If information can be destroyed, then one of the pillars of modern physics is wrong. When you fall into a black hole, you are made of information. Your unique arrangement of atoms, the specific neural connections in your brain that hold your memories, your DNA, all of this is a vast, complex set of information. As you are crushed at the singularity, all of that information about you seems to vanish from the universe. Your past, your identity, everything that made you who you were is erased. It's not just that you die. It's that the universe forgets you ever existed. The quantum record of your life is wiped clean. This paradox has led to decades of debate. More recent theories, like the holographic principle, suggest that the information might not be destroyed after all. It might be encoded on the surface of the event horizon like a two-dimensional hologram of the three-dimensional object that fell in. But even in this scenario, the you that is made of matter and energy is gone. All that might remain is a scrambled, two-dimensional echo of your quantum state plastered on the edge of the black hole for eternity. Your existence as a physical being is over, and what's left is a piece of cosmic data, unreadable and inaccessible. Number 9, your mass is recycled over eons. In 1974, Stephen Hawking made a stunning discovery. He combined the principles of general relativity with quantum mechanics and found that black holes are not completely black. They should glow very faintly with a type of thermal radiation. This is now known as Hawking radiation. The mechanism is complex, rooted in the quantum idea that empty space is not truly empty. It's a bubbling soup of virtual particles that pop into existence in pairs of particle and an antiparticle and an antiparticle, and then almost instantly annihilate each other. But if this happens right at the edge of a black hole's event horizon, it's possible for one particle to fall in while the other escapes. The particle that escapes carries energy away from the black hole, and since mass and energy are equivalent, E equal mc squared, the black hole loses a tiny bit of mass. Over immense periods of time, this process causes the black hole to slowly evaporate. A stellar mass black hole would take an unimaginably long time to evaporate, something like 10 to the power of 67 years. That's a 1 followed by 67 zeros. The current age of the universe is only about 10 to the power of 10 years. When you fall into a black hole, you add your mass to its total. That mass, your mass, will eventually be radiated back out into the universe as part of this slow evaporation process. The particles that come out are random thermal radiation. They are mostly low energy photons and other particles. They carry no information about what fell in. The energy that was once you will be returned to the cosmos, but it will be in the most generic, featureless form possible. So, in a sense, you do escape, but it's a posthumous escape. It happens over a timescale that makes the age of the universe seem like the blink of an eye, and the you that escapes is not you. It's just a random spray of thermal energy. Your substance is recycled, but your identity is lost. This process is the ultimate form of cosmic decomposition. Just as a body on Earth decomposes and its atoms are recycled into the soil and plants, your mass energy is recycled back into the universe. But the process is infinitely slower and more complete. It is the slow, patient, and final dissolution of your physical being back into the fundamental energy of the cosmos. Number 8, your brain loses its grip on reality. The final moments of your consciousness would be a chaotic and confusing storm. Your brain is an electrochemical machine. It relies on a delicate balance of chemicals and electrical signals to function. It also relies on sensory input from your body to build a coherent model of reality. As you are spaghettified, all of this breaks down. The tidal forces would be pulling your skull apart. This would create immense, uneven pressures on your brain. The physical structure of your neurons would be stretched and torn. The carefully balanced chemical environment would be disrupted, blood flow would cease as your circulatory system is destroyed, oxygen would be cut off. The signals from your body would be a nonsensical scream of pure agony. Your proprioception, your sense of where your limbs are, would be gone as your limbs are literally detached from your body. Your sense of balance would be meaningless. Your vision would be a chaotic swirl of distorted starlight and blackness. In this state, your brain would struggle to make sense of anything. Consciousness, if it persists at all, would likely be a disjointed hallucinatory nightmare. The electrical signals in your brain would fire randomly as neurons are destroyed. This could trigger flashes of memory, random images, sounds, and emotions, all jumbled together without context or logic. It would be the neurological equivalent of a television losing its signal and displaying pure static. But this static would be made of the raw material of your own thoughts and memories. Your entire life could flash before your eyes, not as a coherent narrative, but as a shattered mosaic of fragmented moments. This state of chaotic consciousness would be mercifully brief. The destruction of your brain's physical structure would be rapid and total. The electrical activity would cease. Thought, consciousness, and sensation would end. Your subjective experience of the universe would be extinguished. The final horror is not just physical destruction, but the complete and utter breakdown of the mind's ability to perceive and understand its own annihilation. Number 7, you are crushed into nothing. The singularity is the end of the line. It is the central point of the black hole where all the matter that has ever fallen in is crushed. According to general relativity, the singularity is a point of zero volume and infinite density. It is a place where a mass equivalent to millions of suns is compressed into a space smaller than an atom. As the stream of your subatomic particles reaches the singularity, it is subjected to the ultimate compression. The forces are so great that the very nature of matter is changed. Protons and neutrons are squeezed together until they merge into a new state of matter. The space between particles is eliminated. The particles themselves may be crushed out of existence. What is the state of matter at the singularity? We don't really know. Our theories break down. Some ideas suggest it could be a quark-gluon plasma, a state where the quarks and gluons that make up protons and neutrons are freed and form a kind of subatomic soup. Other, more exotic theories propose things like preon stars, or that matter is converted into pure information or a different form of energy. The key point is that your matter ceases to exist in any recognizable form. The fundamental particles that once made up your body are merged into the single, undifferentiated mass of the singularity. You become one with the collapsed star, the consumed planets, the interstellar gas, and every other astronaut unlucky enough to have fallen in before you. There is no distinction left between your particles and theirs. The gravitational force at the singularity is, in theory, infinite. This means the tidal forces are also infinite. The stretching and squeezing that began with spaghettification reaches its ultimate conclusion. Any structure, no matter how small, would be instantly obliterated. This is the final act of physical destruction. It is not just death. It is the complete and utter annihilation of your physical substance. You are not just broken down into atoms or subatomic particles. You are compressed into a point of mathematical infinity where the concepts of you and matter no longer apply. Number 6, your very substance becomes unrecognizable. Let's look deeper at what happens to the stuff you are made of. In normal conditions, matter is made of atoms. Atoms are made of protons, neutrons, and electrons, and protons and neutrons are made of even smaller particles called quarks, which are held together by gluons. The laws of quantum chromodynamics describe this world. As you approach the singularity, the immense pressure and temperature created by the gravitational collapse would have a profound effect on this structure. Long before you reach the singularity itself, the stream of your particles would be subjected to conditions far more extreme than the core of any star. The pressure would be so great that it would overcome the forces that keep quarks confined inside protons and neutrons. This is a process called deconfinement. The protons and neutrons would essentially dissolve, releasing their constituent quarks and gluons. Your matter would transform into a state known as quark-gluon plasma QGP. QGP is a real state of matter. Scientists have created tiny, fleeting droplets of it in particle accelerators like the Large Hadron Collider by smashing heavy ions together at nearly the speed of light. It is believed to be the state of matter that existed for the first few microseconds after the Big Bang, before the universe cooled enough for protons and neutrons to form. This plasma is a hot, dense soup of free-moving quarks and gluons. It behaves more like a liquid than a gas. The very substance that defined you as being made of normal matter has been transformed into this primordial, exotic state. The building blocks of your atoms are now unbound and intermingled in a chaotic fluid. This is a more fundamental level of destruction than simple spaghettification. It's not just your structure that's gone, the very type of matter you are composed of has changed. You have been reverted to the state of the very early universe. This quark-gluon plasma would then be crushed into the singularity, its final fate unknown. But your last identifiable state would be as a droplet in this cosmic primordial ocean. Number 5, you might become a hologram. The information paradox and the problem of what happens to the information of things that fall into a black hole has led to some of the most profound and strange ideas in theoretical physics. One of the leading potential solutions is the holographic principle. The principle was first proposed by Gerard Hooft and later developed by Leonard Susskind. It suggests that the information content of a volume of space can be fully described by a theory that lives on the boundary of that space. It's like a hologram. A two-dimensional piece of film can store all the information needed to project a three-dimensional image. In the context of a black hole, the holographic principle suggests that all the information about everything that has ever fallen into it, including you, is not destroyed at the singularity. Instead, it is somehow stored or encoded on the two-dimensional surface of the event horizon. So as you fall through the event horizon, a holographic record of your quantum information is imprinted on its surface. Your three-dimensional body continues its journey to the singularity and is destroyed. But a two-dimensional scrambled version of you is left behind, woven into the fabric of the horizon. This hologram would not be a picture of you. It would be a vastly complex and scrambled dataset containing all the information that defined you at the quantum level. It would be completely unreadable, but according to the theory, it would be a complete description of you. From the perspective of the outside universe, you have, in a sense, been turned into a flat layer of information on the surface of the black hole. This idea is highly theoretical and far from proven, but it's a serious proposal from some of the world's top physicists. If it's true, it means that while your physical body is annihilated, a ghostly informational echo of your existence persists. You are simultaneously destroyed in the center and permanently recorded on the edge. It's a bizarre form of immortality where you exist only as a complex piece of code on the most extreme hard drive in the universe. Number 4, you could exit into another reality. When the laws of physics break down at the singularity, it opens the door for speculation. While the standard model of a black hole ends in a crushing singularity, some more speculative theories propose other possibilities. One of the most famous is the idea of a wormhole or an Einstein-Rosen bridge. This idea suggests that the singularity might not be an endpoint, but a gateway. The immense curvature of space-time might connect to another region of space-time. Falling into a black hole could, in theory, mean you exit from a white hole somewhere else. A white hole is the theoretical time reversal of a black hole. It's a region of space-time that nothing can enter and from which things can only exit. So instead of being crushed, your stream of particles would pass through a throat, connecting the two and be ejected into another place in our universe, or perhaps even into another universe entirely. This is a classic trope of science fiction, but it has roots in the mathematics of general relativity. However, there are major problems with this idea. Most calculations suggest that any such wormhole would be incredibly unstable. It would collapse the instant anything tried to pass through it. The very act of you, the observer, entering the wormhole would likely trigger its collapse, sealing you inside and crushing you anyway. Other theories related to quantum gravity, like loop quantum gravity, suggest that the singularity is not a point of infinite density. Instead, they propose that quantum effects would prevent a complete collapse. Gravity would become repulsive at extremely high densities, causing the infalling matter to bounce. This could lead to the idea that a black hole is a gateway to a new baby universe that expands from the bounce. These ideas are at the very edge of theoretical physics. There is no evidence for them. But they represent a sliver of possibility that the end is not an end. The horror, however, remains. Even if you were to survive the journey and emerge somewhere else, you would have been spaghettified into a stream of fundamental particles. The you that emerges would not be you. It would just be your raw material, a cloud of quarks and electrons spat out into a new and unknown cosmos. Number 3, your existence reduces to pure math. What is a singularity? In physics, it is a point where a physical quantity becomes infinite. In the case of a black hole, it's a point of infinite density and infinite space-time curvature. But what does that actually mean? It means our physical theories, which are expressed in the language of mathematics, can no longer describe the situation. The equations return infinity as an answer, which is just the math's way of saying, I don't know. As you fall toward this point, your physical attributes are stripped away one by one. Your biological structure is gone, your molecular structure is gone, your atomic structure is gone, even your subatomic structure is gone. You are reduced to a collection of fundamental particles defined only by their quantum properties: mass, charge, spin. At the singularity, even these properties are merged into a single entity. The singularity itself is described by only 3 numbers: its total mass, its total charge, and its total angular momentum spin. These are the only things that an outside observer can ever measure about a black hole. This is called the no-hair theorem. Black holes have no other features. Your individual contribution to these numbers is infinitesimal. Your mass is added to the black hole's mass. Your charge, which is likely near 0, is added to its charge. Your angular momentum is added to its spin. And that's it. Your entire existence, all your complexity and history, has been reduced to a tiny change in 3 numbers. You have become a piece of pure data, a mathematical abstraction. You are no longer a physical object in any meaningful sense. You are a set of properties that have been absorbed by a larger mathematical object. The final horror is not one of physical pain, but of existential erasure. You are simplified out of existence. Your life, your body, your mind are all rounded down to a statistical contribution to a point of infinite simplicity. Number 2, your final sensation is oblivion. What is the very last thing you would experience? This is a question about the intersection of physics and biology. Let's assume you're falling into a supermassive black hole, so you cross the event horizon conscious and intact. The spaghettification process begins after you are inside. The stretching forces would build. At first, it might be an uncomfortable sensation, then a painful one. Your nerve endings would fire, sending signals of extreme distress to your brain. This would be the most intense pain imaginable, as every part of your body is simultaneously pulled apart. But your nervous system is a physical object. It is also being stretched and destroyed. The nerve fibers that carry the pain signals would be elongated and snapped. The synapses, the connections between neurons would be pulled apart. At some point, very quickly, your nervous system would cease to function. The signals would stop. The pain would end, not because the damage has stopped, but because the system designed to report the damage has been obliterated. Consciousness would likely flicker out at this point, as the brain is deprived of oxygen and its physical structure is compromised. If consciousness were to persist for a fraction of a second longer, what would it perceive? Not pain, not sight, as the visual cortex is destroyed, not thought, as the neural networks that support it are gone. Or it would be a state of pure content, less awareness, a blank screen. This state would last for only an infinitesimal moment. Then, the neurons themselves would be torn apart at the molecular level. The electrochemical activity that constitutes consciousness would cease completely. The screen would go from blank to black. The final sensation is the cessation of all sensation. It is oblivion. It is the abrupt and total end of subjective experience. One moment you exist as a conscious being, and the next you do not. There is no white light, no life flashing before your eyes, no transition. There is only the end of the signal. The ultimate horror is that the universe does not provide a final, meaningful moment. It just turns you off. Number 1, you never really disappear. This may seem like a contradiction, but it is rooted in the most fundamental law of physics, the conservation of energy. The first law of thermodynamics states that energy cannot be created or destroyed, only changed from one form to another. And Einstein's famous equation, E = mc squared, tells us that mass is a form of energy. When you fall into a black hole, you are destroyed in every meaningful sense of the word. Your body, your mind, your information, all are gone. But the mass energy that you are made of is not. It cannot be. Your mass is added to the mass of the black hole. You make the black hole infinitesimally heavier. This added mass increases the black hole's gravitational pull. It slightly increases the size of its event horizon. Your contribution is tiny, but it is real and it is permanent until the black hole evaporates. Over eons, as the black hole radiates away its mass via Hawking radiation, your mass energy will be part of that radiation. It will be released back into the universe in the form of low-energy photons and other particles. This energy will travel through the cosmos, perhaps being absorbed by a distant gas cloud that will one day form a new star. That star may one day have planets, and on one of those planets, that energy might be used by a plant to fuel photosynthesis. The particles that are you will be gone. The structure that was you will be gone. But the fundamental stuff of your existence, your little piece of the universe's total mass energy, will be conserved. It will be recycled. This is not a comforting form of immortality. It is a cold, physical one. It is the universe's ultimate statement of indifference. You as an individual do not matter. Your life, your dreams, your identity are fleeting. But the energy that powered your existence is a permanent part of the cosmic ledger. You will disappear completely, and yet, in the most fundamental way possible, you will be part of the universe forever. Your substance is returned to the whole, stripped of all that made it special. You are erased, and you are eternal.